So welcome back. Picking up where we left off, we're going to be in Polynomials lesson 4. We're going to start looking at the different theorems. Before we left, I told y'all that dividing polynomials and the different theorems of polynomials and like solutions. So these 3 lessons, lessons 3, 4, 5, are going to be probably the most important. Well, I don't want to say most important. It's going to be one of the harder, or what I would say harder, lessons were, because it's strictly definitions, especially for your different theorems. Okay, so I'm going to hit you with 4 definitions over the course of the next couple of days. Today we're going to look at the remainder theorem and factor theorem. Before some of y'all left, you actually already caught on and knew what remainder theorem was and what factor theorem was indirectly when we were dividing polynomials, whether it had been long division or synthetic division. Some of y'all started asking me some really good questions, and I kind of hit you with the I don't know, maybe, we'll have to see kind of thing. So you're going to get verification here. It's going to be pretty cool. Again, today what we're going to work on is the remainder theorem, factor theorem. We're going to go through some examples, then turn y'all loose on quizzes. All right, so remainder theorem, factor theorem. Turn to page 15 in the packet. And what we're going to do is I'm going to give you the definitions, the notes, the meat and potatoes behind the remainder theorem first, and then we'll go in and fill out the stuff for the factor theorem. Okay, I need to finish the tree map right here. Alright, so remainder theorem. Pretty much what its name says, it's used to find the remainder when you divide polynomials. So I could have lumped these next 2 things into dividing polynomials. However, they're all theorems, so I chose to group them up into their own particular lesson. So how do I use the remainder theorem? So essentially what we have here is a 2-step flow map. Okay, so 1 and 2, anytime you see this stuff is essentially going to be a flow map. Okay, so how we get started, you want to set your divisor equal to 0 and solve. Alright, so in this example, my divisor is x minus 2, so I'm going to set it equal to 0 and solve. By now, you know when you solve, you're always trying to get variable by itself. Quickly go back over again, 95% of the time, you can solve for variables by doing order of operations backwards. Okay, and then the opposite of the sign you see. Don't overcomplicate this. Some of y'all will see a pattern in this. I'm not going to actually give you the pattern. If you can find it, great. Okay, so x minus 2 equals 0. Solve for x, do the opposite of subtraction, so I add 2 to both sides, and I wind up with x equals 2. Okay, so that's step 1. Step 2 is I'm going to plug, or I'm going to substitute whatever I get from step 1 into the top polynomial and evaluate. Okay, and this is kind of step 3 if you want to say it. Result is your answer. So step 2 is I'm going to plug in x equals 2 everywhere I see an x. So again, everywhere I plug in something, I put parentheses. After doing this so many times, so often, it's just kind of second habit to me now. You don't have to do it. However, I advise you to. It's one of those things, if I always do it, I should never make a mistake. 2 cubed is 8. So 8 plus 6 times 2 is 12 minus 7. Negative times the 8 is negative 8 plus 12 minus 7. Negative 8 plus 12 is minus 4. So plus 4. Made a mistake right there. It's okay. Positive 4 minus 7 is negative 3. This is my answer. This should be my remainder if I did everything correctly. There's a couple of ways you can go back and verify and double check. One is to do it by hand. Again, synthetic division is quicker if you can do it. Remember, your divisor has to be a linear term. The leading coefficient of your divisor must be a 1. Again, essentially the same process. Put it in a box up here at the top. We take our leading coefficient, making sure not to skip. So we have a negative 1, a 0, a 6, a negative 7. Bring negative 1 down. We multiply negative 2, negative 4, positive 2, positive 4, negative 3. Again, remainders always at the bottom right. So my remainder is negative 3. Another way that you can go through here, quickly double check, get your answer, and essentially do these questions without getting it wrong, is to come up here to Desmos. Okay. And we're going to type f of x. So if you think of your top function actually being a function, just call it f of x and type what it is. Negative x raised to the third power plus 6x minus 7. And again, we wanted to evaluate, so when we evaluate f of x, we want to evaluate it at what makes our divisor 0. So evaluate x, we're going to replace the x with a 2, and it gives us negative 3. And I'm done. It's that simple. Don't miss these questions, okay? So y'all are really good at doing this stuff by hand. You can go through here, do it by hand. You can verify it 2 separate ways. I'm going to suggest you go here. If you looked at me doing the example, I messed up probably 2 or 3 times. If you put a parentheses around this negative x and then raise it to the third power, it could mess it up potentially. If it was a squared, it could mess it up. Sign changes are going to be big issues. When we were like rushing through or trying to do like speed challenges when it comes to synthetic division, we kind of messed up in signs a little bit, okay? That's why I like Desmos. F of x, set your top piece of the polynomial as a function. F of x, g of x, I don't care, okay? What does it equal? Blah. Hard part, the only thing you really got to do by hand, set the bottom equal to 0, solve for it. F, G, whatever the function name of whatever that value was at the bottom right is going to spit you out your answer every single time. Okay. Now, from here, what I can do is then use or go to the factor theorem. Okay. So just like with remainder theorem, like the purpose for this theorem is kind of sort of in its name. Okay. The purpose for the factor theorem is to tell if something is a factor of a polynomial. Okay, so you use the remainder theorem to answer the factor theorem. So if when using the remainder theorem, and the remainder is 0, I made a typo here, then the expression is, alright, so cross this out, that's my mistake. If when using the remainder theorem and the remainder is 0, then the expression on bottom is a factor of your top. Okay, so this is essentially yes, no. Okay, kind of questions how they're going to ask you. Is this a factor of this? Yes, no. Tell me why. Your answer is either going to be yes, because when I plug the bottom into the top, the remainder is 0, or the answer is going to be no. When I evaluate the top after setting the bottom equal to 0, plugging it in, the remainder is not 0. So it's that simple. So if I want to use the factor theorem for this example over here, I'm going to say x minus 2 is not a factor of negative x cubed plus 6x minus 7, because when I evaluate the top function or piece of the polynomial, the remainder is negative 3, which is not equal to 0. Therefore, it's not a factor. Okay. So if I want to do this one really quick, again, step 1, I have to do it by hand all the time. X plus 6 equals 0. Subtract 6 from both sides. When I do, I have x equals negative 6. From here, I'm going to say f of x equals negative 2x cubed minus 12x squared. And that's the only thing I need to do. And then I just need to do f of negative 6 equals, does it equal 0? Okay. If yes, then it's a factor. If no, then it's not a factor. So, negative 2x cubed minus 12x squared, and then f of negative 6, it equals 0. So, does f of 6 equal 0? Yes. Then it is a factor. And I'm done. Okay. I'm going to go to page 16. I'm not going to waste a whole bunch of time going through all of these 8 examples. I'm going to do 2 of them. Again, I'm going to do 1 and 2. Then I'm going to let y'all do 3 and 4. And you'll hear me going through over 3 and 4 as well, to see if you got the question right. Okay, so again, just quickly watch me do question 1. Maybe pause it on question 2. Go through and see if you can get what the remainder is. Is it a factor? And then 3 and 4 is going to be on your own. Okay, so starting off with question 1. So this is the top. This is the bottom. Again, step 1, set bottom equal to 0. K minus 2 equals 0. Add 2 to both sides. K equals 2. Okay. Second thing I'm going to do is say k cubed minus k squared minus k minus 2. All right. Does k of 2 equal 0? Yes or no? So, come back to Desmos. I'm going to say function. This time it's k. K is my variable. And now f of 2, where my polynomial is k cubed minus k squared minus k minus 2. F of 2 equals 0. Or excuse me, this would be f of 2. I'm sorry. Equals 0, and the answer is yes, so it's a factor. All right. Here is remainder theorem part. Down here at the bottom is factor theorem. All right. So again, I'm going to go through question 2 again pretty quick. Let's see if one or two things. Find a remainder when I divide this by this. Second thing, determine if it's a factor or not. All right. First thing I do is b minus 7. equals 0. Add 7 to both sides. I get b equals 7. Second thing is do f of 7. Okay. So b to the fourth minus 8b cubed minus b squared plus 62b minus 34. F of 7. F of b is my variable. I have b to the fourth minus 8b cubed minus b squared plus 62b minus 34. Again, when I evaluate it, I have 8. So f of 7 equals 8. So this is my remainder. And I can say b minus 7 is not a factor. Again, reason it's not a factor is I have something that's left over. Y'all, again, so this is where y'all were already telling me. When we were started dividing numbers, you said, no, Mr. Harrell is not a factor because there's stuff left over, right? My remainder is not 0. When we started dividing polynomials, you said, oh, so is the remainder always going to be 0? No, because just like with dividing numbers, with polynomials, your remainder can be anything. It's ultimately going to depend on what you are given in the problem. So, y'all do question 3. Okay. In question 3, tell me the remainder. Also tell me is x plus, or excuse me, n plus 8 is or is not a factor of, I'm just going to say the top. Okay, and again, here goes the top. So, find that for me. All right. So, you should have got your answer. You'll have gotten feedback if it was right or wrong through the play pause it video. Really quick. Step 1, set bottom equal to 0. N plus 8 equals 0. Subtract 8, subtract 8. N equals negative 8. I'm going to then plug this in to my top. F of n equals n to the fourth plus 9n cubed plus 14n squared plus 50n plus 9. Evaluate function f at negative 8. I got negative 7. So the remainder was negative 7. And my answer as far as being a factor, it was not a factor because f of negative 8 did not equal 0. Alright. Y'all go through here and do number 4 as well. Again, I want you to answer, or I want you to find what's the remainder. Okay. Then tell me p plus 5 is not a factor of the big polynomial. Again, you will have gotten feedback through play pause it. Here we go. First step, p plus 5 equals 0. Subtract 5 both sides. When I do, p equals negative 5. When I do p equals negative 5, I'm going to plug that in. I'm going to evaluate it. So, f of negative 5, negative 5. Another thing here, slow down like y'all are extremely, extremely smart. Don't be like your teacher and try and go too fast. Plus 6p cubed plus 11p squared plus 29p minus 13. That tells me my remainder is negative 8. Because my remainder is negative 8, p plus 5 is not a factor. Again, key takeaway here. If your remainder is anything other than 0, it's not a factor. Okay, because I have stuff left over. If I ask you to tell me factors of 42, some of y'all say 2. Okay, well, if I do a factor tree, 221, 2 times 21 equals 42. There's nothing left over. It goes into it perfectly with nothing left over. So there's no remainder. All right, guys, that's it for me. If you have questions, post them on Canvas. There will be a instruction where to. If we do have questions, I'll look at 5, 6, 7, 8, try them, and give me. You can email me or do whatever, and I'll try and walk you through. Maybe you can figure out where you messed up at. As far as the assignments go, assignments are on quizzes. Again, look at your announcements and you'll find all of that good stuff.